this exercise, we're given a regression model that involves an indicator variable, early, and we're asked to find the mean for some certain values of the explanatory variables. So the first question is, what is the mean number of flowers per plant for units in the late treatment group? We can write this same question down symbolically. So we're interested in the mean. We're talking about the number of flowers. We're not told anything about the light intensity, so this will be a function of the light intensity. But we are told something about whether it's early or late. Since these units are in the late treatment group, this tells us about the early indicator variable, and it tells us that that early indicator variable will take the value 0. These were units that did not get the early treatment. So this is the mean we have to find. To find it, we can now take the regression model we're given, and we're going to substitute in any values of things that we know. So we've got an intercept beta 0 plus beta 1 times light. We weren't asked to find the mean for a particular light intensity, so we're going to leave light in there as light. Plus beta 2 times early. We know the early indicator variable in this case takes the value 0. Plus beta 3 times light. Again, we don't have any specific value for that. Times the early indicator variable, and again that takes the value 0. So we can do some simplification. We're still going to have a beta 0. We've got a beta 1 times light. Our third term, beta 2 times 0, that's just going to be 0, so we don't have any contribution there. And then this term, light times 0, is going to be 0, and 0 times beta 3 is going to be 0. So there's also no contribution from that term there. So the mean number of flowers per plant for units in the late treatment group is beta 0 plus beta 1 times the light intensity. So the mean still depends on the light intensity here. Okay, so that's the first question answered. The second question asks, what is the mean number of flowers per plant for units in the early treatment group? So same idea. We can sort of translate this into symbols. We need the mean number of flowers as a function of light. Again, we're not told that that should take a particular value. We are told what treatment group we're talking about here. So because these are units that receive the early treatment, our early indicator variable will be 1. And once again, we just start substituting into our regression model with anything we know. We've got a beta 0 plus beta 1 times light. Plus beta 2 times our early indicator variable. In this case, it takes the value 1. Plus beta 3 times light times our early indicator variable. Again, takes the value 1. And then we want to multiply things out. We have a beta 0 plus beta 1 times light. A beta 2 times 1, it's going to give us a beta 2. And our light times 1, that just gives us light back. So we also have a beta 3 times light. Okay, so that's enough to give us the mean flowers per plant for the units in the early treatment group. We might go ahead and simplify this a little bit more and group the terms together. But you can see light occurs twice here. So we could simplify that out. Let's do that down here. So I'm going to keep the terms together that don't involve light. There's a beta 0 and a beta 2. So beta 0 plus beta 2. And I'm going to put the terms that do involve light together. There's a beta 1 and a beta 3 times light. Okay, so that answers the question. The thing to note here is that the mean for these two categories, they're both straight line functions of light, but now they have different intercepts and different slopes. So the intercept for the late group is beta 0. For the early group, it's beta 0 plus beta 2, so they differ by beta 2. And the slope with respect to light for the units in the late treatment group is beta 1. And the slope with respect to light for the early treatment group is beta 1 plus beta 3. So the slope there differs by beta 3.